Good morning, one and all. Today, we are going to see a circuit in a Norton's theorem. Take down the circuit. In a circuit, compute the current to the ammeter resistance. Use Norton's theorem. So, current through ammeter resistance, we need to uh, calculate by using the Norton's theorem. So, this is a it is kind of a Wheatstone bridge kind of thing. So here the ammeter is in the center of center part. So 5 ohms here, 5 ohms, 8 ohms, and 2 ohms. So it is connected to a battery source of 20. Okay, so what is the first step? So first we need to remove the whatever the ammeter resistance across this point A and B. So just we need to remove, and from here we need to find out the by using Norton's theorem. Here, so you need to find out the short circuit current. Short circuit current. So what I'm doing is I'm redrawing the above circuit and short circuit the load terminal. So load terminals I have short circuited and redrawing the above circuit like this. Okay, so I have redrawn and short circuit here. So now how to find out this IN? The best way is to find out by using the mesh analysis or loop analysis. So here I am taking this current is, so current across this point, that is short circuit current or IN we need to find out. So this loop current I am taking as I1, this loop I am taking as I2, and this loop I am taking as I3. Now we need to apply the KVL in the loop number 1. So by applying the KVL, so the current is flowing like this. All resistance are we are considering as drop. So now all resistance drop means -8. So -8 into I1 minus I3. Okay. Next -5 into I1 is equal to 0. Okay. By simplifying this, you are getting the answer as -13 I1 plus 0 I2 plus 8 I3 is equal to 0. Take this as equation number 1. So the equation we got it as like this, and we have taken as equation number 1. Now applying the KVL in the loop 2, now the current is flowing like this. So all we are considering as drop. So -2 into I2 minus I3. Next minus 5 I2 is equal to 0. By simplifying this equation, we are getting the equation as 0 I1 minus 7 I2 plus 2 I3 is equal to 0. Take this as equation number 2. So why I have taken this as 0 I1 means here there is no I1 component. So for you using in scientific calculator, it will be very easy to input this thing. So here only I1 and I3 terms are there. Now I added a 0 I2. Okay, 0 I2 current as 0 I2. Okay, so it will be easy for you to input into the your scientific calculator. Now applying KVL across the loop 3. Now loop 3 is what? So this is the loop 3. So the current is flowing like this. So the current is flowing to minus to plus. So minus to plus is raise. So raise is positive. Now the current is coming like this. So it is -8. Okay. So in this resistance is dropped. So -8 into I3 minus I1. Again -2 into I2, I3 minus I2 is equal to 0. Okay. So simplifying this, we are getting the equation as 8 I1 plus 2 I2 minus 10 I3 is equal to -20. Take this as equation number 3. By solving this three linear equation by using the scientific calculator, we get the current I1 is equal to 2.73 amperes, I2 as 1.26 amperes, I3 as 4.43 amperes. Now, easily you can say what is IN. So IN is what? I1 minus I2 is nothing but IN. Okay, so I1 minus I2 is nothing but IN or ISC. So I1 is what? We found out 2.73 minus I2 1.26. So simplifying this, we are getting the Norton's current as 1.47 amperes. Now, what is the next step? Next step is to find out the RN. So next step, open circuit the current source and short circuit the voltage source. So across this, we need to find out RN. So any voltage source, we need to short circuit and open circuit the current. So there is no current source. So only one voltage source was there in the circuit. So just we are simply short circuiting this voltage source, and we need to find out what is the RN across this point. RN across this point. So now you can simply solve this. What I'm doing is I'm redrawing the circuit such that it will be very easy to simplify the circuit, and easily you can calculate the Rn. So now across these 2 points only we need to find out the Rn. So across the A and B point. So what I did is I am taking A point here and B point here. Across this point I need to find out Rn. And C and D are connected to short circuited to a wire. So whatever the current flowing this to C is nothing but D, because it is short circuit wire. No? So C and D point is almost same. So I am taking this point as C and D point. Now across this A and D point, 5 ohms is there. So I have taken this 5 ohms. Across this A and C also again 5 ohms are there. So that also I have taken here like this. Now across this B point, you see, across to B point to C point, 8 ohm resistance is there, that I have taken. Across this C point to B point, 8 ohm resistance is there. Now across this D point to B point, D point to, because C and D are same, no, same point. Across this D point to B point, 2 ohms is there. That also I have taken. Now this 5 ohms and 5 ohms are in parallel, and 8 ohms and 2 ohms are in parallel. Now 5 ohms and 2 ohms are 5 ohms and 5 ohms are in parallel. So two same resistance are in parallel means the resultant is that resistance divided by 2. So R equal to 5 divided by 2, that is 2.5 ohms. Now 8 ohms and 2 ohms are in parallel. Okay, so this 8 ohms and 2 ohms are in parallel. So 8 into 2 divided by 8 plus 2. So that is nothing but 1.6 ohms. Now these two are in series. You see here, this two are in parallel. So our resultant is in series, because we need to find out what is across this point only. Okay, so these two are in series. That is 1.6 ohms and 2.5 ohms are in series. So just simply you can add. If it's series resistance, you need to add. So what is Rn? Rn is 2.5 plus 1.6. So resultant is Rn is 4.1 ohms. That is the answer for this Norton's resistance. Now we need to frame the Norton's equivalent circuit. Norton's equivalent circuit. First, we need to take the Norton's current and Norton's resistance, that is in parallel. So Norton's current we calculated already, that is Norton's current 1.47 amperes. So that we are taking in parallel, and Rn also we are taking in parallel, and current through this particular point. Load resistance is what? Load resistance we don't know, because in the problem load resistance is not given. Just they asked to calculate what is the compute the current through ammeter resistance. So load resistance is not given. So just like that, we have taken as this load resistance as like this. Okay, this we have taken like this. So this is the current flow, current through this ammeter resistance. Okay, so the current through this ammeter resistance, opposite resistance divided by total. So here we don't know the ammeter resistance. Just they ask the current through this ammeter resistance. Okay, so here there is no resistance value, so we can't able to calculate. So just like that, we are drawing the Norton's equivalent circuit. That's all. This is the answer for this particular problem.